Section 5 on page 691 is on solving rational equations. So a lot of the stuff we've been doing lately, we've been working with expressions. There has not been an equal sign, and so we haven't been solving anything, we've just been simplifying. Today we're going to look at equations. We're solving equations. We're trying to figure out what value of the variable would make this equation work. So if you look at problem 1, they want us to find this solution. So finding the solution, one option you have is to multiply and get rid of the denominator. It's kind of like looking at what would be our common denominator, but since there's an equation, since these two things are equal to each other, we're allowed to multiply by something to eliminate the denominators, and then we don't have to worry about fractions from that point. So if you look at these denominators, we've got 12, 2x, and 3x. So with the numbers, we need a 12. With the variables, we need an x. So 12x would be our common denominator. What we're going to do then here is multiply by 12x. When we distribute that to everything, the fractions will be gone. So you can see with that first fraction, the 12's cancel. We still have an x we're multiplying by. That would be the 5x that they got down here. With the second fraction, the 12 and the 2, you can reduce by 2, and then the x's can cancel out. So that leaves us with 6 times 1, which is 6, and that was a minus in between there. On the other side, the x's cancel. 3 and 12 you can reduce by 3, and that leaves us with 4, and then 4 times 1 is 4. So you can see out of all that, it looked like a little bit of a mess there, but now we are sitting pretty good with a two-step equation. 5x minus 6 equals 4. So now this is looking a lot better. So then we just add 6 on both sides and then divide by 5, and we would get x equals 2. At that point, you can check your answer. Check your answer. Just substitute 2 back in for x in the original equation, and you can see that it works. So we know we got the right answer there. So let's look at the got it 1, part A. I'm going to rewrite this just so I've got a little bit more room. So to eliminate the denominators, we would need to multiply by 3x. We need an x, we need a 3, so altogether we need a 3x. So I'm going to take my original equation and I'm going to multiply by 3x on both sides. On the left side, since we have two terms, I'm going to make sure I put that in parentheses so that I make sure I'm going to distribute to both of those terms. On the right side, I only have one term, so I don't really have to worry about distributing. I'm just going to be multiplying to that one term. So the 3x you can put over 1, and it's probably not a bad idea just to rewrite it like the book did. Now on the right side, since there's only the one term, I'm going to go ahead and simplify that. So we're multiplying. These are all factors, so we can reduce by a factor of x. And then we got 3 times 2, which is 6. On the left side, now that we just have one term times one term, we can reduce by 3. So that would be 1x or just x. And then the second part, we can reduce the x's. And then we've got 3 times 3, which is 9. So out of all that, we come out pretty good. X plus 9 equals 6. We actually only have one step that we need to do. They're adding, so we subtract 9. So x equals -3 would be our answer. Then if we go over and look at part B, Similar story in part B. I'm going to rewrite it just so I've got a little bit more room. So looking at the denominators, these are all monomials. So we would need, with the 3's and 7's, we would need a 21. And then we also have an x. So we need to multiply by 21x to get rid of our fractions. So it's like 21x over 1. On the left side, might be good to distribute that. And that's where we have to be careful. Temptation there might be to try and cancel things out. You can't cancel unless it's just one term times one term. If you have something times a binomial, you don't want to start canceling that because that has to get distributed to everything. On the right side, we can go ahead and start reducing because that is just one term times one term. So the x's can cancel, and the 3 and the 21, we can reduce those by 3. That would leave us 7 times 7, which is 49. So on the left side, with the first terms, we can reduce by a factor of x. And then the 21 and 7, we can reduce by 7. And so we basically end up with 3 times 4, which is 12. With the next part, we can reduce by 3. So we would have 7x over 1 times 1, which would be 7x. And then if this really bothers you, you can rearrange these if you like, I guess. But otherwise, you got a two-step equation here. So next we can try to get the x term by itself. This is a positive 12 here, so we need to subtract 12 to get rid of it. And then the last step is they're multiplying. We need to divide by 7. We can't reduce this, so we could leave it like that, or you could make it into 5 and 2/7. Don't do a decimal. It's not going to be nice on this one for sure. And fractions recommended anyway. Since we don't really know what's going on with this equation, like what our purpose is of solving for this variable, it's not like a real life problem. Probably if you leave it as 37/7 would be fine. Problem 2 just talks about how sometimes when we're solving these, we may have to end up factoring at some point. So if you look at problem 2, same idea as we did before. If you look at the denominators, we have an equation, so we're allowed to multiply on both sides to try to clear out our fractions. We have an x and we have an x squared, so they said let's multiply by x squared. So they distributed here, and then after they reduced, they got x squared minus x equals 12. Notice on this problem, we have a squared term and an x term. We also have a constant hanging out on the other side of the equation. So that would be our cue that we want to set this equal to 0 and then try to factor this. Remember, if it doesn't factor, the other options would be trying to complete the square or using quadratic formula. This one does factor, and so then we have two potential options. Either x could equal 4 or x could equal -3. What we have to do, though, we have to make sure we don't have any extraneous solutions. So they checked this out, and they actually both work. So 4 and -3 would work for this problem. So that would match up with answer choice C that they had. So if you look at the got it number 2, part A, we are trying to solve this equation. So again, I'm going to just rewrite that so I've got room. So to start off with, to clear out our fractions here, we could multiply by y squared on both sides. This time it's kind of switcheroo. The left side is the side where we only have one term, and the right side is the side that we need to distribute on. And then just make sure you take in consideration the subtraction sign there. So with the first terms on the right side, you can either go ahead and multiply, would be 6y squared over y squared, or you can reduce both of these by y squared. Those would cancel out. We'd have 6 over 1, which is the same as 6. And then the last part, we would get 6y squared over 1, which is just 6y squared. So at this point, we see a squared term and a y term and a constant. So we are going to want to set this equal to 0. Rather than negative 6y squared, I would rather work with a positive 6y squared. So what I'm going to do is say I don't like it on the right side being negative. If I get it on the left side, then it should be positive then. So we can add 6y squared on both sides. And then also we can subtract 6. If you want to do that as a separate step, you can. You don't have to do it all in one step to get it set equal to 0. But you have that option if you want to. And then at that point now we have a trinomial set equal to 0. So now we can try to factor this as two binomials. To get the 6y squared, if we go with our closest factors, that would be 3y and 2y. We've got minus 6, so we know one has to be positive and one has to be negative. If you'll notice, our sign in the middle is positive, so we need more positives. So we can take a gamble here if you want and put the positive over on the right side with how I've got it written, because then that would be 3 times the positive number and 2 times the negative number, which would give us more positives. Factors of 6, we've got 1 and 6, 2 and 3. If we try the closer factors would be 2 and 3. Now remember, if we do this, I'm not going to put it this way because then that would have common factors, and I didn't have a common factor that I could have factored out of that to start with, so I can't have one now. So it can't be that way, so I'm going to try it the other way. And if we do that, that would be minus 9y minus 4y, which would be a positive 5y. So that gets us what we want, so that works. So now if that times that equals 0 means at least one of those factors is equal to 0. And then if we just finish solving that, first one would come out as 2/3. And the second one comes out as negative 3/2. So those would be our two possible solutions, potentially. At that point, we would want to substitute that back in to the equation and make sure that they work. And I'm not going to go through that whole process because I know you guys are capable of figuring that out, but they actually do both work, and so both of those are solutions for this problem. Again, though, make sure you are checking for extraneous solutions. So if we look at part B, we've we got a similar idea here. One thing different on this problem they're kind of throwing in that we haven't seen yet is the one denominator actually is a binomial, so that's a little bit different. Let me just rewrite this. On the left side, I'm going to put that over 1. And then we're going to try to multiply to get rid of the denominators. So to get rid of that, we would need to multiply by d plus 3 on both sides. On the left side, we are going to have to distribute that. If you'll notice on the right side, the d plus 3's are going to cancel out. So left side, we can distribute that. And then we can combine like terms in the middle. So at this point, we're going to try to set this equal to 0. Notice on the left side, we already have a positive d squared term. So I'm going to leave that where it's at. I'm going to get everything else over on the same side. So we can subtract d and subtract 11 on both sides. Remember, that's like a minus 1d. So that would give us d squared plus 8d plus 7. And then on the other side, that all cancels, so that's equal to 0. And then we're going to try to factor this. So that would factor out as d plus 7 times d plus 1, or d plus 1 times d plus 7. And so that means either d plus 7 equals 0 or d plus 1 equals 0. So that would say either d equals 7 or d equals negative 1. Once again, it would be good to check those answers just to make sure that they both work. And it ends up that they do, so those would be our solutions for that problem. And then just to mention on part C, they're asking how could we tell that that rational equation has no solutions just by looking at the equation. So just by looking at this 2 over x squared equals negative 1, they're asking how could we tell that that would have no solutions without working it out. So the reason here is if you look at this, we got 2 over x squared. 2 obviously is a positive number, and x squared, if you square something, regardless whether x is positive or negative, if you square it, you multiply it by itself, then it's going to end up being a positive number. Positive times positive is positive. Negative times negative also is positive. So we have a positive number divided by a positive number no matter what can't be equal to a negative number. So that's the reason why this equation would have no solution. Now, if you don't recognize that, if you were actually working this problem out, you could multiply by x squared on both sides, and you get 2 equals negative x squared. What's different on this problem is we just have a squared term and a constant. We don't have just an x term. So in this case, there's different ways you could do this. One option, since it's the only term, you could either just add x squared and subtract 2 on both sides, or you could just multiply both of them by negative 1. And then you could take square root plus or minus. And here's the problem, is trying to take a square root of a negative number. So that tells us we have no real solution.